Okay, so I'm going to go ahead and explain a little bit about the 68, 95, 99.7 rule. This rule is also known as the empirical rule. So this rule says that if your distribution is normal and it is symmetric about the mean, then these things will be true. So your mean is going to be here at the peak, and the mean is now symbolized with this symbol here, a U with a little tag or tail in front. It is the Greek letter mu. And what the empirical rule says is that if you go one standard deviation out in each direction, one SD in each direction, then this will be approximately 68% of your data. If you go two standard deviations out from your mean, so there's 2 total in this direction and 2 total in this direction, then this is approximately 95% of your data. And lastly, let's see here. If you go 3 standard deviations, again 3 from your mean in each direction, then that is approximately 99.7% of your data. Now, why is this helpful to us? Well, let's say we have the following. Let's say that we have some test scores, and the mean is equal to 80, and the standard deviation is equal to 5. This is your symbol now for standard deviation. It's a sigma, Greek letter sigma. And so let's go ahead and look at the following. We could go ahead and say test scores 68, 95, and 99.7. So what we can do is we can draw a bell-shaped normal curve. We can put our mean right here at the peak of our distribution, which will be 80. And then what we're going to do is sketch out the distribution in terms of standard deviations away. So I'm going to add 1 standard deviation in each direction, and I'm going to subtract 1 in each direction. I'm going to do the same thing one more time, and one more time. Come in. So if we had to list out the test scores that are contained, that contain about 68% of the data, then that would be 1 standard deviation away in each direction. So 68% of the data would be contained between the scores of 75 to 85. 95% of the data would be within 2 standard deviations away. So that would be from the score of 70 to the score of 90. And then 99.7 approximately percent of the data will be 3 standard deviations away. And so that would be from the score of 65 to 95. Now, keeping that chart in mind, hang on, we're going to undo. Keeping that in mind, right there, what we're going to do is answer a few questions. All right, so what percent of the data is between 75 and a score of 90? What percent of the data is between a score of 75 and a score of 90? Well, when we did this about the mean, we knew that 68% of our data was contained within one standard deviation from the mean. But this is symmetric about the mean. So if we cut this 68.5, I know that 34% of the data is contained right here between 75 and 80. So now all I need to find is what percent is from 80 to 90. Well, from 80 to 90 is 2 standard deviations from the mean, and we know that 2 standard deviations from the mean is 95% of our data. But we only want the upper half, so we're going to take that 95 and divide it by 2. And when we do that, we get 47.5. And so this part here will be 47.5. So if we want to know the grand total of approximately what percent is between 75 and 90, I'm going to add the 34 and the 47.5 for a grand total of 81.5%. We'll do one more question like this. What percent of our data, let's say what percent of our data is going to be between, what percent of our data is going to be greater than, let's say, 85. All right, so from 85, well, we know that 50% of our data will be from our mean and below. So that's 50%. And so we need to go, we're going to look at our 85. Score of 85 is right here. It is 1 standard deviation from the mean. So again, we know that this is 34%. So if all of this area that I'm shading in black has a grand total of 84%, and the whole area under the curve is equal to 100%, then I know that the remaining part, let's shade here in yellow, that I want, that's greater than 85, has to be 100, take away the 84, which will be 16%.